Hello, hello, hello. Okay. Mm. All right, my ninja warriors. I am here and let me set. Sometimes this camera setting, I don't know how it just changes. Yes, Ninja Ma'am is right here. Can't you see? Please confirm whether Ninja Ma'am is audible or and visible or not. Yes, everyone. Ma'am, you already taken the complex number chapter before 3 months? Is it? Is it? Hmm. No. No. Oh, yes. Hmm. Oh, you are right. No. 3 months before, yes, I can see, but that's only one session I can see. Acha, it actually I couldn't finish the chapter, right? Mm-hmm. Okay, all right. Why fear when Ninja Ma'am is here? Kya baat hai? Very nice, very nice. Comeback video. Yes, tomorrow you will get. Cube root of unity is also not taken. Yes, actually today's session is going to be very important session for complex numbers, right? And ma'am, you Cetaphil on your pimples. Can you see my pimples? Huh? Ninja Ma'am is past Cetaphil era. Now Ninja Ma'am is into IPL, laser, right? And so many things. Chemical peels also sometimes. Okay. So don't worry, Ninja Ma'am is having a good dermatologist. Okay. So gradually, hopefully, you'll see some improvements in my acne. Thank you for showing concern. Okay. One student is saying, Ma'am, I'm just finished watching yesterday's class. I'm sad I missed the live session. Hmm. All right. So it's good now. If you have watched the session, then it's good only, right? Ma'am, maximum time duration of this session, the duration of this session is going to be approximately 2 hours, less than 2 hours. Let's see. Okay. Yes. Ma'am, you are my teacher mom. What is teacher mom? Huh? New words, new things you are keep on inventing. Live session, I can ask doubt. It's better. Okay, cool. If you feel that, that's good. Okay. All right, everybody. Chalo, everybody has settled down, correct? Shall we start today's session? Ready, ready, ready. Give me a big thumbs up and also make sure that you're smashing the like button. Yes, Rishit. Ninja Ma'am, tricks, big fan. Kya baat hai? Very nice. Thank you so much. Rishit, welcome to the session. Ma'am, I'm nervous about JEE Main in January. Don't worry because tomorrow I am going to drop a beautiful video that how to that is going to be absolute game changer mindset shift of yours. Okay, so don't worry. And a little bit nervousness is positive only, it's healthy only, unless it is becoming obstacle in your preparation. Okay, all right. Yes, all right. So the previous class was all about, let me just go through previous class a lot. Okay, previous oops you guys are writing comments and I have something to say, but I mixing up. Oh, okay. So before we start for today's session, let me talk about complex number, which we have already studied. So we spoke about modulus. Okay, modulus formula you should know, number one. And modulus geometrical significance is so important. Along with that, we have seen properties of modulus and properties of conjugate, right? Then don't forget about the hero property of complex number, because JEE Main asked so many questions from that hero property. Can you tell what is the hero property? Ma'am, while doing maths, I feel that I am ninja ma'am myself. That gives me confidence. What comment you are posting? Nice, good confidence. Confidence is very good in mathematics. In fact, you know what? Sometimes I feel, every time actually, I feel mathematics paper is based on confidence. 50% confidence, 50% subject knowledge, question knowledge, and you're good to go. Okay? Yes. All right. One student is saying, mom means who teaches the life same way you teach me mathematics, so you are like my mom. Very nice, very nice. Huh? Very different kind of comment. Okay. So I don't have kids right now in my life. So you are my kid only. Right? Remember my name Rishit, cause I am getting 99 percentile. Okay. So if you are going to get 99 percentile, come back and make sure you comment that, ma'am, I am studying in this college and I have got this much score. Okay. This video will be here only. And your comment will stay here. Okay. All right. No need of watching old lecture. Huh? You can go and watch old lecture also, but you can watch this as well. Okay. So let's start. Let's start with the very first question over here. If you can see, everyone, the very first question, and I want you to do this. I want you to try this question, especially all those students who were already there in my last class. I want you all to do that question, okay? And I'm going to give you hint as well. By the way, this is again hero property will be used, and this is the same category. You know what? These kind of questions only come in JEE, trust me. Okay. So, ma'am, but can you see the scary looking equation? You know what? Why students are scared of complex number? Because the moment we see this, we don't even know what to do. Okay. One student is writing Hero, Honda, Splendor, Ninja Ma'am, Thunder. Oh God. Such a creative people you are. Chalo, now come back. Enough things. Enough we have spoken about. Now let's come back. This is the kind of question JEE Main's favorite, NTA's favorite, and your least favorite. Because the moment you see this question, you're like, I don't even know from where shall I start. Okay. So let me tell you that what we are going to do is hero property of complex number. Nobody is writing only, right? Hero property is z bar is equals to mod z square. Okay. You know what? There are a couple of properties only in complex number which are useful. So the moment you see any question, you just think about what do I know in complex number and how can I apply that particular knowledge in this question. Sometimes what we do is we just sit down and just see this and we become blank. No, think about whatever you have studied, the highlights of complex number, the conjugate thing, then and you know what? Important. Hero property, how can you forget? Can hero property be fitted in this question? Definitely yes, because there is mod of something square. So the moment you see mod of something square, what you're going to do is mod of something square. So 1 minus z1 bar z2. And this is 1 minus z1 bar z2 and whole bar. Can you see what did I do? This is mod of something square. And I am trying to write it z bar. So this is this expression and z bar. Are you understanding? Okay. Minus sign. Now again this z1 minus z2 and z1 minus z2 whole bar. This is your LHS. Okay. This is your LHS. So we are picking LHS only. Let's figure out the LHS and then pick RHS part. Okay. Now what we are going to do is we are going to just keep on solving using whatever properties we already know. Now see this. This is actually one conjugate. One conjugate is one only. Remember the properties of conjugate, right? Properties of conjugate, how to apply? Now this is Z1 bar, one more bar. So this is minus Z1. Z1 bar, one more bar. This is Z2 bar. Okay, so this is how it is coming. And what about this? Again, this is actually Z1 bar minus Z2 bar. So Z1, Z1 bar. Okay, hold on. Z1, Z1 bar is mod Z1 square. Z1, Z2 bar. Okay, so this is Z1, Z2. So minus Z1, Z2 bar. Then minus Z2, Z1 bar and minus minus plus. This is what? Z2 and Z2 bar. Z2 and Z2 bar will be Z2 mod Z2 square. Okay? One by one, step by step. Okay? Alright. Now multiply. 1 ones are 1. Okay? Then this is minus Z1, Z2 bar. Correct? This is minus Z1, Z bar, Z2. And if you multiply this and this. Z1, Z1 bar together. So minus minus plus. This is Z1 square and Z2 square. Okay? So this is what we are getting over here. Minus sign. Now let's focus on this. This is what? Mod Z1 square only. Let's just copy only, right? We can't do anything in this much more. It's already solved plus mod Z2 square. Now let's see if we can actually, this is plus Z1 square, Z2 square, okay? This is minus, see, Z1, Z2 bar minus plus, cancel. This also cancelled out, okay? So this is what? 1 minus Z1 square, Z2 square. And this is what? Minus sign. This is Z1 mod Z1 square plus mod Z2 square. This is what we are getting. This is my LHS. Everybody, this is my LHS, right? Now let's talk about RHS. So if I just multiply RHS, 1 ones are 1 minus, it would be what? Mod Z1 square minus mod Z2 square and minus plus mod of Z1 mod of Z2 square. This is your RHS. Everybody getting it? Now let's compare. So ma'am, 1 here, 1 here. Okay, 1 same to same. Minus Z1 square. Minus Z1 square is here. Minus Z1 square minus Z2 square. So ma'am, these two terms also. And you know what? This is plus. Plus, okay, can you see LHS and RHS is same to same? LHS and RHS is same to same. Can you see? What does that mean? Find the value of K. If LHS and RHS is same to same and this K, I mean this part, that means K is equals to 1. So from this, K will be just 1. Give me a big thumbs up. Give me a big thumbs up. Hello ma'am, your all-time follower here. Anytime you keep class, always online, is it? Okay. Today, so I don't know, like what kind of students have came, because I have not seen you. So many people I have not seen you. Yes. All right. Next question. Next thing. Let's talk about argument. Which, by the way, argument thing. Please tell me that yes, ma'am, Ninja ma'am. Yesterday's session, you actually taught what argument is, right? So what we are going to do is we are going to focus on argument, which is also known as amplitude of a complex number. Please understand the two aspects of complex number are very important. Number one, modulus. Number two, argument. If you know modulus and argument now, that means you know complete complex number. If you just know modulus, that means you don't even know complex number. Just little information. But these two information, modulus and argument, if you have that, that means complete complex number. You know, you don't need anything more. Okay. Now let's start. See, P is a point A comma B, right? Representing a non-zero complex number. Now if OP, see, this is your point P, which is representing a complex number A plus iota B. That's why A comma B is that complex number, right? Now OP, O is the origin. Now OP is making theta with positive direction of x-axis. So theta will be argument or amplitude. And you know what? In this particular case, theta will be, tan theta will be B by A, or theta will be tan inverse B by A. Correct? Okay. Now you know what? this principal argument. So we are going to talk about principal argument. Amplitude, understand now, amplitude can have multiple values. So if I say that a complex number is making 30-degree angle, right? 30 degree means pi by 6. Pi by 6 angle with the positive direction of x-axis. Somebody can come that pi by 6 actually is equivalent to 2 pi plus pi by 6. Same position. The angle is also correct. Okay. All right. And yes, you guys are writing comments. I can't teach. I should stop looking at the comment section. Yes. Now, yes, what I was telling you is that theta, right? Pi by 6. Pi by 6 angle is same as 2 pi plus pi by 6, 4 pi plus pi by 6. But you know what? This is amplitude, and amplitude can have multiple values. But principal argument, my dear students, principal argument is fixed and it is unique, and the value lie between minus pi open to plus pi close. Okay. Otherwise, unless otherwise stated, argument z refers to the principal value of z. Okay. What are they trying to tell you is, whenever they are writing arg z, that means they are referring to the principal value. This is the interval. You have to give your answer in this specific interval, and that value will be unique. Nobody can come and question that, oh, pi by 6. Why is this pi by 6? It could be 2 pi plus pi by 6. No, it is pi by 6 because the interval is defined, and in this interval only unique value can exist. I hope that you're getting my point. Now, see general argument. So I told you 2n pi plus theta. Okay, so that is how it is. And also 0 plus 0 iota. Okay, then in this case, you know what? This point is the complex number. That means if you ask me that what this point is making which angle with real axis, so it is not defined only. Okay, so this is a special case. Only a complex number whose argument is not defined. Now, I have told you in yesterday's class, that we'll take 4 cases. Quickly, I am going to revise because this is already been covered in yesterday's class. Working rule for finding principal argument, right? Now, if your A and B both are positive, that means your complex number will lie in first quadrant, and hence theta will be nothing but alpha. What is alpha? Alpha is tan inverse B by A. But now if your complex numbers lies in second quadrant, that means your A is negative and B is positive, correct? So in that case, it is going to be pi minus alpha. Pi minus alpha will be what? Pi minus alpha tan inverse mod B by A. Okay. Now case 3, third quadrant. Third quadrant may just apply a negative sign to case 2 and you're going to get the answer. So it was pi minus alpha. This is alpha minus pi, and in fourth quadrant, my dear student, it is going to be just negative of the first quadrant. So simply minus alpha, my dear students. Okay. All right, everybody. Yes. So this is your 4 quadrant at one place: alpha, pi minus alpha, alpha minus pi, and minus alpha. Okay, dokie. Yes. Perfecto. Right. Now, please note, very important, if you have a complex number whose real part is 0 and imaginary part is positive, that means 2 iota. So 2 iota kind of numbers will lie on the positive y-axis or positive imaginary axis. So when your complex number is lying on the positive imaginary axis, just like z is equals to 2 iota, so this type of complex number is having argument what? Pi by 2. That means purely imaginary complex numbers. Purely imaginary. Louis, you were there in last class, right? Yeah, in last class I have explained exactly the angles I have calculated and explained. Right now the argument we are just revising that concept. Okay. Yes. So it is positive imaginary axis. The argument is pi by 2. And if it is negative imaginary axis, that means argument is minus pi by 2. So a purely imaginary number is having either plus pi by 2 or minus pi by 2 as the argument. A greater than 0 and B equals to 0. Okay, A greater than 0. So now the number lies on positive real axis. Then your argument is 0. But if number lies on purely real negative axis, then your argument Z is pi. Clearly, this is making pi angle. Okay, so either it will purely real number if it is positive, then 0 degree. Okay, or 0 radian also. And if it is purely real negative number, -2, Z is equals to -2. What is argument? So argument is pi. Okay, now I will give you a couple of questions and I want all of you to tell me the argument of following numbers. Yes? Question time, learning time, everybody, quickly. Rohint, you are not even aware about the high weightage things. I don't know what are you doing, huh? You are not even sure about the weightage of any chapter. And you know what? Multiple times I have made a video of high weightage chapters. Multiple times. And not even videos, I have spoken about this in many other sessions as well, that which one is high weightage, which one is low weightage. If you are not aware that which one is high weightage, which one is low weightage, then what are you doing, huh, Rohit? I think some people are actually not giving their 100%. They are randomly coming and they want to ace in JEE main. Why is it happening? I am not sure. Why are you doing that? It will actually give you stress. Okay, you are always under prepared. What happened? Some people are always under prepared. Some people from the beginning, they don't even know their syllabus. They don't even know the high weighted chapter. Forget about anything else. Forget about any question or anything. Okay, find the argument of following. Okay, find the argument of following. So this is which quadrant, ma'am? Third quadrant. What is the formula of third quadrant? Alpha minus pi. Alpha is what? Tan inverse modulus of b by a. So tan inverse 1 by 1 minus pi. So pi by 4 minus pi, minus 3 pi by 4, my dear students, minus 3 pi by 4. And in fact, you know what? Even if you are forgetting the formula, don't you think things are pretty easy? This is -1 comma -1 and you are looking for which angle? This angle is what you're looking for. Obviously, this is negative 3 pi by 4. Now this x is positive but y is negative. Can you see x positive, y negative? Fourth quadrant. So fourth quadrant, what is the angle? Minus alpha is the angle. So minus alpha is the angle, fourth quadrant. So minus of tan inverse y by x or b by a is root 3. So this is going to be negative pi by 3. Okay. And -7, my dear students. -7. Okay. -7 is a negative real number. So clearly, ma'am, pi is the answer. Yes. Okay. And this is 4 iota positive imaginary number, purely imaginary, pi by 2. These last two, so I think, are very clear. Yes, everyone. I can see that you guys are giving me answers as well, but very few are giving me answers because rest people are talking among each other. They are busy in talking. Some important discussion is going on. Okay. Chalo. Now let's talk about the next question on your screen, everybody. Okay, this is very important. This conceptual understanding of this question, you know what? Conceptual understanding of this question will enable you to solve so many JEE main tough questions. Okay, so please make sure that you are understanding this. All right, yes. So let's start with find the modulus and argument. So clearly, modulus, mod z, everybody, is what? Square root of real part of square plus imaginary part square. Square root of 1 plus cos square plus sine square is 1 plus, this is going to be what? 2 cos 2 alpha. Correct? Okay, so mod z is going to be what? Square root of 2 plus 2. So 2 if you take common, 1 plus cos 2 alpha. 1 plus cos 2 alpha. Do you remember the formula, everybody? It is nothing but mod of 2 cos alpha. Okay? Because see, 1 plus cos 2 alpha, you know the formula is nothing but 2 cos square alpha. Okay? So this is root 2 actually. Or directly we can do one thing. No? This is square root of 4 cos square alpha, which is what? 2 mod of cos alpha. Okay? 2 mod cos alpha. Yes, range is minus pi to pi. Yes, definitely. What happened in that? Anything, any issue in that? Remembering? Okay, anyway. Mod cos alpha. Now cos alpha. Tell me quickly. Mod cos alpha. First of all, tell me the alpha. Alpha lies in which quadrant? Can anybody guess? Okay. You don't have to guess. It is given, right? Alpha, ma'am, second and third quadrant, right? Second and third quadrant. ASTC. In both second and third quadrant, your cos is negative. Okay? So you definitely cannot write this as 2 cos alpha. Modulus is not 2 cos alpha. Modulus is always positive. Please understand. Now if your alpha is from second or third quadrant, you're going to put the value of alpha and your modulus is going to be negative. Okay? So what you have to do is to compensate this, you have to apply a negative sign because you already know this is definitely going to be negative. To make it positive, if you apply, balance it out one negative sign and you're going to get the modulus. This is the modulus, okay? Now argument. Argument depends upon in which quadrant your complex number lies in. Okay? Argument depends upon in which, see, this is your x, this is plus iota y. So let's talk about this, x, okay? For calculation of argument, you have to understand. This is x. X is what? 1 plus 2 cos square alpha. 2 cos square alpha, correct? So 2 cos square alpha, ma'am, square is there too, so this is positive. So x is positive in this case, okay? And sine 2 alpha, y is what? Sine 2 alpha. So ma'am, hold on. When alpha is from pi by 2 to 3 pi by 2, 2 alpha will be what? 3 pi to pi, correct? 2 alpha is what? Pi to 3 pi. Pi to 3 pi. Hold on. This is your pi and this is your 2 pi, then this is your 3 pi. Is it? 2 alpha we are talking about now. So 2 to cancel. Sine 2 alpha. So it seems ASTC. So pi to 3 pi. Pi, 2 pi, 3 pi. Pi to 3 pi. Okay. Between pi to 3 pi. See, 0 to pi, pi to 2 pi. Pi to 2 pi is negative and 2 pi, so that means sine 2 alpha can be either positive or negative, both. The 2 is always positive, so the sign depends on cos alpha. That's why we write modulus as absolute value. That is why we write I'm not sure whether you're asking doubt or what, but yes. Hold on. So this is going to give you what? Yes, sine 2 alpha is 2 sine alpha cos alpha. We can write this 2 sine alpha and cos alpha. Okay, now tell me. Sine alpha. Okay, sine alpha is what? See, this is in second quadrant. Suppose we are having second quadrant. Let's see that if you are having alpha in second quadrant, what is happening? Sine is positive and cos is negative. So overall thing is going to be negative. So if it is second quadrant, this is going to be negative. Okay. Now if it is in third quadrant, ASTC. In third quadrant, what happens is sine 2 alpha becomes what? Positive. Why? Because see, sine is negative. in third quadrant, and cos is also negative. So overall, you're going to get positive. That means y can be either positive or negative. That we have to see. Okay, that we have to see. So x is clearly positive. That means x is positive, y is positive. Either it is in first quadrant, my x and y, and or either it is in, because x is positive, in fourth quadrant. Okay, so we need to take cases. Case number one. Case number one, where your alpha is lying in second quadrant. If it is lying in second quadrant, so we know my answer will be what? Pi minus tan inverse mod of, okay, let me go back, y by x. So this is 2 sine alpha cos alpha by 2 cos square alpha. 2 sine alpha cos alpha upon 2 cos square alpha. Okay, so clearly 2 cancel, cos cancel, tan inverse tan alpha is going to be just pi minus alpha only. Okay, so this is the argument, everybody. Now if alpha is lying in fourth quadrant, very easy, my answer will be negative tan inverse, same thing. Okay, so negative tan inverse mod of tan alpha. Okay, so this is going to be minus tan inverse, and this is going to be alpha. Okay, and since this is going to be positive, okay, see, alpha is negative now. Alpha is in fourth quadrant, right? Alpha is not in fourth quadrant. Alpha they have given. So what will be your answer? Let me check. Alpha minus pi will be your answer. Okay, let me check. See, modulus, what is happening? Modulus is z is right here. Okay. So mod z is minus 2 cos alpha, as I told you, and argument z is going to be alpha minus pi. So this is already done. Okay. Okay. All right. So alpha minus pi already done and dusted. All right. Now, you know what? Today, let's start now. Let's go beyond argument now. Now you know what is argument, the slight idea of argument, although we are going to do more questions of argument. But now let's talk about different representation of a complex numbers, my dear student. Okay? All right. Ma'am, I didn't understand the Argand plane concept clearly. Can you please clarify it? Pranav, were you there in the first session? Were you there in my yesterday's session or not? Because the yesterday session was all about detailed session about Argand plane only. Now you want me to teach the Argand plane one more time. So that means yesterday's session I will have to repeat. Okay. There is no point. Then we will not go forward. Okay, we are going to get stuck in that. Okay, so I have explained you what exactly you didn't understand about Argand plane. Argand plane, here x-axis is nothing but replaced by real axis. Okay, and y-axis is replaced by imaginary axis. Okay. One student is asking, ma'am, complex number is not important, na? No, we are so randomly I am randomly coming and teaching you because it is not important. So let's teach it. Okay. So yes, do not study. All right. Anyway, chalo, let's start. Let's understand. You know, Cartesian form, algebraic form, z is equals to a plus iota b. This we have already studied. It can be translated to Argand plane a comma b. Correct. Then we have iota is square root of minus 1. Real part of z is a, imaginary part of z is b. Z bar also you know, a minus iota b. Mod z is equals to a square root of a square plus b square, and tan theta is this. This is what we already know. Now can you see over here what is happening? Can you see what is happening? This is actually summary of a complex number. Whatever we have studied, it is a summarized form. Okay. Now what we are going to do is we are going to move on and talk about polar and, or we can say trigonometric form, my dear students. Polar / trigonometric form. Okay. Z is equals to a plus iota b. Mod z is equals to r and argument z is equals to theta. So if you are having a complex number, can you calculate modulus? Yes, ma'am, which is denoted by r. Okay. Can you calculate argument z? Yes, ma'am, you have given the formulas. Yes, we can do that. So if you know that, then a plus iota b can be written down as r cos theta plus iota sin theta, and this has one more notation, r cis theta. R cis theta. R cos theta plus iota sin theta, which is nothing but r cis theta. Okay. So this is what your polar form looks like. Clear? So basically now you understand, to write any complex number in polar form, you just need two things. Yes, Louis. Louis is asking good question. Ma'am, how to convert polar form to Cartesian form? Polar form to Cartesian form is not an issue, na? Polar form to Cartesian form is not an issue. Issue is Cartesian form to polar form. Okay. So if you have a Cartesian form, can you calculate r, which is modulus? Yes, ma'am. Can you calculate argument theta? Yes, ma'am. Now put the values in this formula and you're going to get this. Right? And once you multiply and mix up the things, you can go a plus iota b. Okay? Alright. Now let's understand this polar form a little bit in detail before we actually solve proper conversion problems. Okay, we are going to solve the conversion problems, but before that, let's understand a couple of things. R is equals to what? R cos theta plus iota sin theta is nothing but r cis theta. Z bar, that is conjugate of z. So just flip the minus sign over here if you are going to do that. See, plus sin theta will become minus sin theta. So this is r. This is what? Cos of minus theta plus iota sine of minus theta. Okay. So clearly this is what? So written in a different format, because cos of minus theta is plus cos theta only. So basically what I am trying to do is, because it is negative, so I am putting minus sign inside the theta, and to make consistency across the thing. Okay. Alright. So it is going to be r cis minus theta. Okay. Please note that argument of z bar will be what? Minus theta. And you know what? We have seen that. Do you remember we were doing, where is the z located? If z is located here and the angle is theta, so z bar, the angle will be minus theta. This is your z bar, this is your z. So I think this particular thing is clear to you. And also please note that whenever you see cos theta plus iota sin theta, remember that the magnitude will be 1. In fact, cos theta minus iota sin theta also magnitude is 1. Okay, give me a big thumbs up if you've understood this, and we can actually jump on to some questions. Chalo, easy questions, concept building questions before we actually solve a JEE main PYQ. Okay, so over here z bar. See, mod z is given, argument z is given. Okay, so can I just write z? Z is nothing but what? R cis theta 2 cos pi by 4 plus iota sin pi by 4. Correct? And you know what? What is this polar form, everybody? Yes, now one student was asking also. That, ma'am, this is polar form. How to convert it into normal algebraic form? So can you see? This is so very easy, right? So z is what? 2 by root 2 is what? Root 2, 1 plus iota. Okay, 2 by root 2 is what? Root 2. So this is 1 plus. So z bar, very easy now. Root 2, 1 minus iota. That's the answer. Clear, everyone? Yes? Okay, dokie. Alright. Now we have this. Express the complex number in polar form. Ma'am, Z bar is -2. Pranav, I don't think so. You were there in my previous class. If you were there, I have clearly mentioned, okay? You didn't listen to my previous class. I don't agree. I don't believe. Okay? I can catch the lie. Anyway, polar form. So clearly I want R which is equals to -1 square plus -√3 square. So 3 plus 1, so 2. Okay. And now, now argument. Can you see when both x and y are negative, that means third quadrant, -1 comma -√3, third quadrant. And third quadrant has a formula which is alpha minus pi. So tan inverse mod of √3 by 1 minus pi. Tan inverse √3 pi by 3 minus pi. So minus 2 pi by 3 is the argument, everyone. Minus 2 pi by 3. Okay. So z is nothing but what? R cos theta plus iota sin theta. Now put the values. Z will be R. R is 2 cos of -2 pi by 3. Okay. And plus iota sin -2 pi by 3. That's it. No need to solve this because as per the question they are talking about polar form only. Okay. All right. Yes. Please understand that this R is always positive. R can never be negative. If it is coming negative, that means you are doing something wrong. So can you see now 2 cis theta or directly 2 cos minus theta. These two will work. But this cis theta only like us people, it is between us. Okay. Please do not write this cis theta in your board examination. Write it properly. Okay. Although it is not a wrong thing, but you know what, why to take risk, why to become over smart, especially cis is a notation, acceptable notation only, but you know what, please go with this. This is more acceptable if I talk about board level. Okay. All right. Although you can fight with anybody that this is a standard notation, I am going to fight, but why do you want to fight? Choose your battles. Okay. Not every fight you have to fight every fight. Ki acha. If I am right, I am going to fight it. Okay. All right. Now Euler's form. Everybody, Euler's form. Okay, Pranav. Okay, gotcha. Euler's form, very important, and you know what? It is going to be the game changer in complex number if you actually know Euler's form. Because some questions now, you will be like, I am doing 3-4 pages of this question, and eventually that question will be done in just 2-3 steps if you know the Euler's form, because Euler's form is all about exponents. Some questions especially with higher powers. Suppose 1 plus iota power 300, 1 plus 2 iota power 300, these kind of questions specifically. So in that case, 1 plus 2 iota power 300, how are you going to calculate? But if you can actually convert that format into Euler's form, na, so the question will be very different scenario. Okay. So Euler's form, everybody understand, z is equals to a plus iota b. Now if you know the polar form, Euler's form will be cakewalk for you. Okay. A plus iota b, we already know r cis theta, and actually you know what, it is equal to r. This cos theta plus iota sin theta can be written down as e power iota theta, because e power iota theta is nothing but cos theta plus iota sin theta. Here theta is the argument. Now understand, to write polar form you need two things. What? R and theta. To write Euler's form, again you need two things. What? R and theta. Okay. Yes. So now I want all of you to do this exercise so that you understand when exactly Euler's form is used. I told you, whenever you see there are higher powers, power 6 is still manageable, but more bigger powers, that means this question definitely is going to be cracked by Euler's formula or Euler's form. Okay. Z is equals to 1 plus iota root 3 power 6 plus 1 minus iota root 3 power 6. Okay. So first of all, 1 plus iota root 3. Let me write it in Euler's format. For that, I will need r. Clearly, r is what? Square root of 1 plus 3. So 2 is the r. Okay. E power iota theta. Can anybody tell me what's the theta over here? Clearly, that 1 plus iota root 3 is lying in first quadrant. So the angle will be tan inverse root 3. Tan inverse root 3 is what? Tan inverse root 3 is pi by 3. So this is just pi by 3. Agree, everybody? Yes, directly we can write. Now, I minus root 3. 1 minus iota root 3. So again, what do we say? Modulus. Modulus is 2, again same, but e power iota, since x is positive and y is negative. X positive, ma'am, x positive, y negative. Fourth quadrant, what will be the angle? Negative. Minus tan inverse root 3 by 1, so minus of pi by 3 is going to be the angle. Yes, everybody? So if you know this now, if you can write this, now just plug in the value. Z will be what? 2 e power iota pi by 3, okay, power 6 plus 2 e power iota minus pi by 3 and 6, okay. So this is going to give you 2 power 6, 2 power 6 is coming common. And this is what? E power iota 2 pi plus, can you see? Power 6 is there, right? 6 into pi by 3. So, e power minus iota 2 pi. Correct? Now, you already know. E power iota theta is what? E power iota theta is nothing but cos theta plus iota sin theta. Plus this is cos minus 2 pi plus iota sin minus 2 pi. Okay, so clearly sin 2 pi is anyway gone because sin n pi is 0. Okay, so this is 2 power 6. Cos 2 pi is 1. Cos minus 2 pi will anyway will be plus. So this is 1. So 2 power 7 is what? 2 power 5, 32. 2 power 6, 64. 128 is 2 power 7. My dear students, and we are good to go. Okay. All right. Clear? Everybody? Yes? Easy peasy na? Now things have become pretty easy. Now see. Let's see how many of you can do this question. Concept building question again. Okay. This is the second class, my dear students. Okay, yes. Option B. Okay, one student, no. Mod Z is equals to 2 Ninja Ma'am. Ha. Okay. Now please understand, this is your Z. Okay. Z is equals to minus 2 e power minus iota pi by 3. Correct? So people who will be like, okay, r e power iota theta, if you're going to compare, then it looks like that option A could be the right answer. But you know what? Modulus can never be negative. Okay. Yesterday there was first class, bacha, you can just check it out. Today is second class. Okay. Z is equals to minus 2. Now cos minus pi by 3. So cos minus pi by 3 is cos pi by 3 minus iota sine pi by 3. Okay, let's put the value. So this is minus 2 cos 60 degrees 1 by 2 minus iota root 3 by 2. 2 anyway going to get cancelled. So this is minus 1 plus iota root 3. Okay, this is your complex number. This is your complex number. Now, so you can check na x is negative, but y is positive. Second quadrant, the angle is lying in the complex number lies in second quadrant, and hence the angle also lies in second quadrant, right? So second quadrant, pi minus tan inverse root 3. So pi minus pi by 3, 2 pi by 3. So argument z is this, and you know what? Modulus, so everybody can write that it is 2. Okay. All right, done and dusted. Shall we move on to the next thing now? Okay. So let me just load the next content. See, I just don't keep the heavy file, because what happens is, if I'm going to keep heavy file, then it, first of all, it takes some time to get loaded. And you know what, you can think of, ma'am, it is a one-time thing, you can load it. But what happens when the power is not there, power cut is happening, then you know what, after that we have to reload that file, 100 file. So 100 thing means 100 seconds we need to add. Every second, 1 second for one slide it will take. Okay. So I think this is done. And now I want to give one more question. Okay. This is that question. Let's solve this. What is this question? Let's see. Cos theta plus iota sine theta upon sine theta plus iota cos theta. Okay. Yes. Yes. Previous year marathon you can watch. I'll join this videos, Ninja Ma'am. What are you doing? Previous video, and I'll join this video, Ninja Ma'am. Bye. Okay, bye. Okay. Now you know what? This question can be done in actually traditional manner. Okay, traditional manner may it will take some big time, but you know what? Please do it ninja way. Let me teach you ninja way, which is a shortcut. You will think more and write less. Ninja way. Okay. Ninja way. Ninja ma'am says that, okay, you already know cos theta plus iota sine theta. So this though you can easily write, this is e power iota theta. Okay, but what about this? Sine theta plus iota cos theta. What about this? This is power 4. So now what I'm going to do is, I will do one thing, because you know what? Please remember, iota is always with sine theta. Okay, iota is always with sine theta. So if you have sine theta plus iota cos theta, power 4. Okay, what I'm going to do is, I'm going to multiply iota, power 4, or iota inside. Let's multiply iota by iota. Correct? Let's multiply. So that you will get what? Iota sine theta. So this is minus cos theta plus iota sine theta, and this is whole upon iota. Okay, I am talking about this. Now again, minus cos theta. Can, by some manner, we can actually, can we change this? And can we make cos of same angle and sine of same angle? Okay, so for that, yes, actually that also we can do. Pi by 2 minus theta also can be done. Okay, that is also a good thing. Yes, actually we should go with Whatever that student is telling, that is the much easier way of doing this question. Can be done. Yes. So sine theta. Sine theta is what? Cos 90 minus theta plus iota cos theta is sine pi by 2 minus theta. Okay. So ma'am, can I write this as e power iota pi by 2 minus theta? Absolutely. So this is e power iota pi by 2 minus theta. Correct? Okay. So what we are going to do is e power iota, laws of exponent. This is theta minus pi by 2 plus theta. Okay. And power 4 is also there. E power iota, this is 2 theta minus pi by 2 and you have power 4 already. Okay. So power 4 now, you know what? Do you remember a power m power n is a power m into n? Correct? So what we are going to do is e power iota, this to get multiplied. So 4 to the 8 theta minus this is what? 2 pi. Okay. So now let's again open it. Let's open it. So it is going to be what? It is going to be cos theta. So cos 8 theta minus 2 pi plus iota sine 8 theta minus 2 pi. Okay. So this is what? Cos 2 pi minus 8 theta. Cos 2 pi minus theta. Understand? See, in cos theta minus theta can be flipped. Cos minus theta and theta will be same. So we can actually also say that this is 2 pi minus 8 theta. Cos 2 pi minus 8 theta. 2 pi plus 2 pi minus. So this is cos 8 theta. So cos 8 theta plus. What about this? So ma'am, this is 8 theta minus. So can I do this? Minus iota sine of 2 pi minus 8 theta. Sine 2 pi plus and minus. Sine 2 pi minus theta is minus sine theta. So this is cos 8 theta plus iota sine 8 theta. This is your answer, my dear students. A by B is what they are saying, cos theta by sine theta. So this is cos theta by 8 theta. Sine theta is your answer, which is nothing but cot 8 theta. Okay. Now let's discuss the properties of argument. Ready? Ready for properties of argument? So properties of argument, see, Z1 is a complex number, then this is the Euler's form, R e power iota theta 1, this is Z2, R e power iota theta 2, Z3, R e power iota theta 3, Zn, R e power iota theta n, correct? So this is your Z1 complex number which is making theta 1 angle with the x-axis. This is your Z2 which is making theta 2 with the x-axis again, okay? Yes? Ma'am, if we use binomial expansion to solve this, it will be easier now? No, it will not be easier. If you're going to use binomial expansion to solve this, then you have to deal with higher powers of, can you see this question? Huh? And you know what? This is 4 right now. What if it is 16? Are you going to write? Are you telling me that writing 17, 18 steps will be easier than this? This is a generic thing. Even if your power is 100, this method works. But if your power is 100 over here, are you telling me that you are going to write 101 terms of numerator, 101 terms of denominator? Right? Yes. I hope you're getting your answer. That's why I'm telling you now, whenever you see higher powers, major powers, go for, what do we say? Euler's form. Okay, so there is a reason why I am saying this. All righty, everyone. Okay, properties of argument, everyone. See, properties of argument, you know what? Please do not get scared of properties of argument. In fact, I don't even remember everything in properties. I just think that whatever the properties of logarithm is, Same properties in argument, both are same. For example, argument z1, z2 is nothing but argument z1 plus argument z2. So this is the property. Now you'll be like, ma'am, plus 2k pi, what is this? So basically, please understand that your angle should always be, argument should always be between minus pi to pi. So to adjust that angle, sometimes what can happen is this argument z1 plus z2 can go beyond that interval. So your angle is correct. Technically that angle is correct. But you know what? You should be able to be in that limit. So add 2 pi or subtract 2 pi to get it to be in the desirable result. Okay, interval. Okay. Now again, logarithm property asks z1, z2, z3, zn. So it will be argument z1 plus z2 plus z3 plus zn. And to compensate, you have to add 2k pi. Okay. Don't stress upon 2k pi. It is a situational thing. We'll do it. Don't worry. Okay, z1, z2, z3 and z1, if all the complex numbers are equal, what does that mean? What does that mean? Then what will happen? This is also z, this is also z, 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 so this is z power n. Now remember the logarithm, the power comes in front. So this is n argument z plus 2k pi, it's a situational thing. You might not have to do anything in some questions, okay? Second property again, can you see the logarithm property? Log a by b is log a minus log b, same. Arg z1 by z2 is argument z1 minus argument z2. Okay. Now I'll be giving you one question and I will be asking you the answer. Please let me know. Solve this question quickly. Argument z1 into z2 will be what? Argument z1 into z2 will be, ma'am, 160 plus 80, na? Because argument z1, z2 is what? Argument z1 plus argument z2. Plus 2k pi is there, but we'll adjust it, 160 plus 80. So 160 plus 80 will be what? 240. Hold on, 240 degrees. So are you saying argument of z1, z2 is what? 240? 240 though is not in that interval minus pi to plus pi. So for that, either you have to add either 2k pi, if you have basically either plus minus 2k pi. Plus 2k pi. Okay. Okay. So what we are going to do is we are actually going to subtract 360. K is equals to minus 1. Okay. So 360. So this is 240 minus 360 will be your answer, which is what? 60 plus, so minus 100 degree is your answer. In fact, 240 degree if you try, so this is what? 120 degree comes here, 240 degree comes here, right? So, but you know what? What is your interval? Minus 180 to plus in minus 180 to plus 180. So this is your angle. So this angle will be what? Minus 120 only. Correct? Okay. So you have to make sure that my angle should be either in positive first and second quadrant or negative first and second quadrant. Minus 120 degree. Acha, sorry, 120. Yes, it is 120. Okay, all right. Yes. Another question. Shall I give it to you quickly? Chalo. Let's do the next question. Let's do the next question. What is K, ma'am? Where is K? Why are you asking K? I just told you, 2k pi is just to adjust. K could be anything. But k you have to select in such a manner so that your final answer should lie in minus pi to pi. Okay? Yes? So k should be absolutely a unique value. It could be either 1 or minus 1. Usually it will be either 0 or plus minus 1. So you put 0. Plus 2k pi is there in the formula. You were getting 240 degree. 240 degree was not even your interval. Because your argument strictly should lie in minus 180 to plus 180. But now you are saying 240 degrees is the answer. Is it acceptable? No. That 2k pi is to adjust the angle so that it falls it. 240 degrees is not a wrong answer. Technically, it is not a wrong answer, but it is not falling in that interval. Okay, that's the thing. Argument z, so this is 50 times argument z. Can you see? 50 using property, 50 argument z. 1 plus iota, so everybody remember that the answer will be 50 pi by 4. Oh ma'am, easy peasy lemon squeezy questions you are giving. What are you doing? Okay. Anyway, another question on your screen is this. Okay, so yes. Now Z1, Z2 up to infinite term. Z1. By the way, can you see Zk is nothing but e power iota pi by 2 power k. Okay, this is what we are getting. So now Z1, Z2 and all the way up to infinity will be what? Z1 will be what? E power iota pi upon 2 power k. Then e power iota pi upon 2 power 2. E power iota pi upon 2 cube. Okay, basically Z1, Z2, Z3 and all the way up to infinity. So now using this basis same powers will get added. So iota pi by 2, iota pi by 2 square, iota pi by 2 cube and so on all the way up to infinity. Can you see Euler's form? Euler's form, whenever it comes into the picture, then only this question became very easy. Otherwise this question was not easy. If you think that I can do this question without Euler's form, you know what, you won't be able to do this question. The question is easy just because of Euler's form. Okay, so this is e power iota pi by 2. If you take common, it is going to be 1 plus 1 by 2 plus 1 by 2 square and all the way up to infinity. Can you see a geometric progression? E power iota pi by 2 and you know what? Gp of infinite a upon 1 minus r. So this is your 2 to cancel. Can you see 2 to cancel? E power iota pi. E power iota pi is just minus 1. E power iota pi is just minus 1. Okay. Yes. Alrighty, everybody. E power iota pi is -1. Easy peasy. Lemon squeezy. Right? Okay. Now this question, very good question, I would say. Let's see how many of you can actually solve this. Yes, PYQ series will be coming. Don't worry. Wait. Everything will be coming. And in fact, one series is going on already in the morning. How many of you are following? Especially 2026 aspirant, 6 o'clock series. Nobody. Success is possible for every yo, whatever. Are you following 6 o'clock series? Okay. Now, z bar plus iota omega bar is equals to 0. Argument z omega is nothing but what? Pi. Clearly from here, argument z plus argument omega is equals to pi. That is first equation, and this z bar. Okay. So now let me do one thing. Z bar plus iota omega bar. Let's do equals to 0. What I'm going to do is I am going to take conjugate. The moment I am going to take conjugate, this is my conjugate. So this is z bar plus iota bar omega double bar is equals to 0. Okay. Z double bar is z plus iota bar will be what? Iota bar will be what? Minus iota. Omega double bar is just omega is equals to 0. So from here, can I say that z by omega is equals to iota? Z by omega is equals to iota. Yes. So from here now, what we can do is take argument. So argument of z by omega is argument of iota. Argument of z by omega is argument z minus argument omega is equals to argument of iota. Argument of iota is pi by 2. I hope you know that. Okay. So this and this. If you are going to add, okay, so 2 argument of z is equals to pi plus pi by 2, 3 pi by 2. So this is 3 pi by 4. Where are you? 3 pi by 4, option D. Okay. 3 pi by 4, beta. 3 pi by 4. Okay. All right. Yes. I don't think so anybody is getting the correct answer. What happened? Wrong answers, everybody. Chalo. Let's move on to the next question, and this is a JEE main PYQ. Let's see how many of you are actually able to do this. Okay. And you know what? I have a ninja technique to solve this question. But I want all of you to try it at least. Option D, and student is saying, I already know the ninja trick for this. Acha, tell me, Raz Gaming. Did I teach you? Students are knowing ninja technique before even ninja technique is getting invented, huh? What's happening? You are making ninja technique so popular. Direct formula sec theta. What is sec theta? Direct formula sec theta. What is sec theta? I can't understand, one student is saying. Okay, all right. First of all, obviously, in fact, even I see the question. Sometimes, let me tell you, the different JEE aspirants who are going to actually solve this question in different manner. Different JEE aspirant will commit different type of mistake. The very first mistake, the common mistake average JEE aspirant will do. Okay, average JEE aspirant. Okay, he'll be like, oh, this looks like Euler's form, and he'll be like 1 plus, ma'am, this is e power iota theta, and this is 1 plus e power minus iota theta, ma'am. This is what is happening, because he is actually not sure about the formula, right? He is actually misunderstanding the formula. This is not cis theta, this is not e power iota theta, this is a wrong technique. After this, you're going to go absolutely wrong from this. So this is the not at all acceptable. Now the one more student who is slightly more aware about the mistakes he can do, he'll be like, no, this is not cis theta. In fact, I think I need to make this as cis theta. So why can't I multiply iota here and iota there? But what is happening? Not understanding what is happening. Okay. So these are the two kinds of mistake or two kinds of wrong approaches a student takes purely because he hasn't practiced enough. Okay. The only way to get this question correct is to practice these type of questions, practice these type of statements or these type of expressions. Very popular expression. Okay, very popular question. Okay, so now ninja technique says that forget about e power iota theta for now. Please forget about it. Let me just do this thing, that this is my z. Okay, and this is my what? Can anybody tell me? Z bar. And you know what? This z. Can anybody tell me, if this is your z, mod z is what? If I just say that this is my z, mod z, don't you think is 1? So, do you remember now that hero property? See, this is conjugate. Basically, these two are conjugate of each other. Do you remember hero property? Hero property is z bar is equals to mod z square. Z bar is nothing but mod z square. Okay, z bar is nothing but mod z square. Okay, alrighty. So let's apply this thing over here. So this is 1 plus z upon 1 plus z bar whole cube first of all. Okay. Now, you know what? 1 plus z and 1 plus z bar. This z bar will be what? See, since mod z is 1, so basically z bar is equals to 1. This is what you're getting. Z bar is 1. So if z bar is 1, z bar will be what? 1 by z. So this is 1 by z and this is your whole cube. Correct? Now, you know what? Take LCM. The moment you take LCM, this is going to be just z cube. Can you see? Can you see? Z plus 1 whole cube. But one z will be going upwards. So this is z cube. Now put the value of z. Z cube is what? Tell me. So z cube is sine 2 pi by 9 plus iota cos 2 pi by 9. This is your z cube. Okay. All right. Yes. So now in that case, now is the time you should convert. Actually, this is, suppose this is your theta. Let us mark it as theta. So this is sine theta plus cos theta whole cube, right? So this is cos of pi by 2 minus theta plus iota sine pi by 2 minus theta. Okay? Yes, correct or not? And this is whole cube. So clearly this is e power iota pi by 2 minus theta. What is theta? 2 pi by 9. And you know what? There is a cube over here which is eventually going to get multiplied. Now let's solve it. So this is 3 pi by 2 minus 2 pi by 3. So e power iota 3 pi by 2 minus 2 pi by 3. Okay. So now tell me, this is your thing. Okay. Cos 3 pi by 2 minus. So cos 3 pi by 2. 3 pi by 2 is here. 3 pi by 2 minus. Cos 3 pi by 2 minus something. So it is going to be minus. See. Basically e power iota pi by 2 minus theta. Okay. This is your thing and this is power 3. So this is e power iota 3 pi by 2 minus 2 pi by 3. Okay, now let's get back to that cos theta version. Cos of 3 pi by 2 minus 2 pi by 3 plus iota sine 3 pi by 2 minus 2 pi by 3. 3 pi by 2 is right here and minus 2 pi by 3. So this is sine of, and cos is negative, ASTC. So minus sine 2 pi by 3 plus iota, and this is again, sine is again negative in ASTC, right? So negative cos 2 pi by 3, correct? Yes. So now this is minus of root 3 by 2 and this is plus 1 by 2 iota. This is minus root 3 by 2 plus 1 by 2 iota. Minus root 3 by 2 plus 1 by 2 iota minus root 3 by 2 plus 1 by 2 iota is matching with minus root 3 by 2 plus 1 by 2 iota is matching with option C. Good question. Very, very good question. Yes, you will get everything. Wait. Gradually you will get short notes, you will get everything, you will get PYQ sessions. Okay, just stay tuned to this channel. Okay, wait for some days. Okay, this is a good question, I would say. Okay, yes, alrighty. Now the next question I would like to give it to you, and I want you to think on this question. Very good question again. Thoughtful question. It will actually grow your thinking thing. Okay, thinking ability. Ma'am, direct formula is sine plus iota cos theta for this type of sums. This is the short trick. I don't know. Direct formula is this is it a formula? Sine plus iota cos theta, is it a formula? What are you saying? Anyway, chalo, let's see. Real part is what we are looking for in this. Okay, So e power iota theta, so z is equals to e power. Now can you see e power iota theta will be cos theta plus iota sin theta. Okay, so z now will be e power cos theta and e power iota sin theta. E power cos theta, understand now, e power cos theta is actually a real number, and e power iota sin theta looks like this is that Euler's format. So this is e power cos theta, and what about this e power iota anything? This is the angle. So this is cos theta, theta is sin theta this time, plus iota sin of sin theta. Yes or no? Okay. Now see, understand. If you multiply this is the imaginary part and this is the real part. So these two together, e power cos theta and cos of sin theta is nothing but the real part of this, real part of z. This. Okay. Perfecto. Getting it? Alright. So this is how your answer would be. Okie dokie. Yes. Now let me load one more file. Fifth, right? Sixth, right? Six is already there. So let me load that. Import PDF. Okay, so now let's talk about the vector. See, we have done a good questions on Euler's, polar, everything. Okay, let's now see the vector representation of a complex numbers. I mean, you can actually see that this is a complex number which actually can behave like a complex number as well. Okay, by the way, how many of you have done that chapter, dual nature of light? Okay, sometimes it behaves like a particle and sometimes it behaves like a light, like wave nature or particle nature, dual nature. This is actually my favorite topic from physics. Okay, same complex number. Dual nature of a complex number. It can behave like a coordinate and it can behave like a vector. Okay, right? So now every complex number can be considered as the position vector of a point. Okay, so over here this is P point which is representing a complex number which you can see over here. Now this is your Z, right? And you know what, this is your origin, and OP vector is nothing but mod Z. OP vector is nothing but mod Z. Okay, mod Z. That OP vector is nothing but mod Z. Okay, all right, yes. Okay, now let's see addition of complex numbers. Let's see how to add complex number in vector format. So again, triangle law or parallelogram will come into the picture. Suppose this is your Z1 because P point is representing what? Z is a complex number, so this is your Z1 and this is your Z2. Okay, this is Q point is Z2, hence OP is Z1 vector, this is Z2 vector. Now Z1 plus Z2. Understand, Z1 plus Z2 will be what? So this will follow parallelogram law, which is nothing but this. This is Z1 plus Z2 and this is nothing but the diagonal of the parallelogram, which is OR vector. Very basic, very simple, okay? Try to understand this. Now you'll be like, ma'am, but just tell me one thing, that what do you think, like in which context, this vector thing will be required, okay? So let me tell you that rotation of vector is something where this thing will be required, okay? Rotation of vectors. Rotation of vectors, say, understand multiplication of vectors is much important over here. Suppose you have Z1 complex number and Z2 complex number. Z1 is a complex number, Z2 is a complex number. Now the moment you multiply, what is happening? R1, R2 will get multiplied, and e power theta 1, e power theta 2. If you multiply, laws of exponent says that if base is same, you can add the powers, right? So it will be theta 1 plus theta 2. That means the moment you multiply two vectors, the modulus though will get changed. Don't worry about this. I am thinking about what happens with the angle theta. So both the angles get added. Let's see what is happening with respect to graph, okay? So this is your Z1 making theta angle, theta 1. This is your Z2 and this is making theta 2 angle, right? Now Z1, Z2 will be making theta 1 plus theta 2 angle with the x-axis. Now keep that in mind. You might think that, ma'am, this is becoming so difficult, so much of graph and theta 1, theta 2. Don't worry, because first of all, the vector format, only one or two questions of same category JEE may ask from this topic. And you know what? It has very less to do with vector representation. This is more of a JEE advanced concept that we can actually study once we are done with JEE main first attempt, okay? So do not keep this in mind. I am just touching upon all the basics or all the concepts which are involved, okay? So that when I am going to teach for JEE advanced also, na, okay? So then you'll be like, okay, I have slightly I have idea. It's not that I just don't even know this, okay? So this is how it is going to be. Again, when you divide two vectors, what happened? R1 by R2 will be the modulus and theta 1 minus theta 2 will be this. Theta 1 minus theta 2 will be the final angle of Z1 by Z2. Okay, everybody? Yes. Now, let's talk about one very important thing, okay, which is nothing but triangle inequalities, okay? Triangle inequalities again. Now, triangle inequalities, ma'am, please do sequentially CH. What sequentially CH? What do you want? What do you say? I'm not even sure. Yes. So, triangle inequalities, okay? I will try my best to make you understand that triangle inequality is not that difficult as it seems. In fact, when I was studying triangle inequalities in the very first place, now I actually got intimidated. I was like, what is this teacher teaching? What is this? How will I remember this? First of all, how will I remember this? Okay, so basically what we do is we just see some concept and we'll be like, maybe I won't be able to retain this. Let's leave this topic. How many of you think after actually studying triangle inequality or looking at the triangle inequality, you'll be like, ma'am, what is so many modulus? So many less, greater? We don't know. We don't know what to do with triangle inequality. Okay, so we'll talk about it first of all, one by one. Okay, so yes, so triangle inequality, right? First of all, because you have seen that this is your Z1, this is your Z2, and your Z1 plus Z2 is nothing but what? This diagonal of a parallelogram, right? Okay. Z1, Z2 and Z1 plus Z2 is diagonal of a parallelogram. Okay. Or you can say that, are you aware about that vector only? See, let me talk about the vector. Let's not talk about complex numbers slightly. Let's talk about vector. Vector may you all know this is your A vector. This is your B vector. Okay. This is your B vector. So third vector will be what? This is A plus B. Correct? Okay. So now tell me, can I write? This is 9th class statement. You can verify it, Google it. Sum of two sides is greater than third side. Sum of two sides of a triangle is what? Greater than third side. Okay. Sum of two sides greater than third side. Correct? So A plus B is greater than magnitude of A plus magnitude of B is greater than or equal to also. It can be equal. Equality will hold when what happens is A and B are not forming a triangle but they are collinear. So A plus B is what? A plus B only. Correct? So mod A plus mod B. Sum of two sides is, what is third side? A plus. Yes or no? So can you see this is mod of Z1 plus mod of Z2 is greater than mod of Z1 plus Z2. Don't you think this is so obvious? So can you see I have proved this side of inequality that sum of two sides is greater than equality. I have explained it to you, is greater than or equals to third side. This side you know, everybody, yes? Now obviously understand this, that this will always be greater than modulus of difference of Z1 and Z2. Okay. So this will always be like this only. Okay. Subtraction. This is what? Can you see? Subtraction of two sides will always be less than or equals to what? Third side. Subtraction of two sides is less than or equal to from the third side. This is the third side. Okay. So I think this inequality we have understood it nicely. Okay. Now the same thing. Understand this plus sign, just remove it with negative sign and that's it. You have to just follow the same thing. Obviously, now mod of Z1 plus Z2 is what? Less. So mod of Z1 minus Z2 is even lesser. This so we can understand, if plus is lesser, no, minus will be either much lesser, and this is the same thing. Okay. So I think if you can understand this, you can replicate this over here and two inequalities will be right in front of you. Okay. So just make sure now after this you just write. After this you just write and you just write the inequality and try to solve a question. See, I'll tell you, I am going to help you in solving one question so that you understand triangle inequality a little better. Mod Z plus mod Z minus 2. What are they talking about is minimum value. Correct? Minimum value. Okay. Now we know that this is the triangle inequality. Okay. So this is what? We know that mod of Z1 plus mod of Z2 is greater than or equals to mod of Z1 minus Z2. The second inequality I am talking about. Second triangle inequality. Okay. So again, mod of Z plus mod of the Z2 will be Z minus 2. So this is greater than or equal to mod of this minus this. Now can you see this minus this is what? Plus 2 only. This minus this is plus 2. That means this thing is greater than or equal to 2. That means minimum value is just 2. Done. The answer is done. Can you see? Just by applying, it's just that you have to click it. Now you'll be like, but ma'am, how do you know which inequality will be applicable? See, right now they are talking about the minimum value of mod of Z1 plus mod of Z2. I'll go back. Minimum value of mod of Z1 plus mod of Z2. Okay, so minimum value will be what? This. Mod of this is minimum. Okay, mod of Z1 minus Z2. That's why I chose this inequality. Okay, all right, everybody. Yes, clear? All right. Now, one more thing apart from triangle inequality, trust me, not all the time you're going to get the triangle inequality, but now whatever I'm teaching you, the geometry behind complex number, this is so important for JEE. Please learn it. Even if you ask me, ma'am, what to skip in complex number, so I will tell you want to skip vector thing, go ahead, skip it. You're going to ask me, ma'am, triangle inequality, can I skip? Yes, you can go ahead and skip triangle inequality as well. But if you're going to ask me, ma'am, I'm going to skip this, please don't do that. Number one, it is easy, and number two, it is important. Okay. So very simple thing, mod of Z minus Z naught. This we have discussed in previous class. Mod Z minus Z naught is R. Here Z naught is the center, R is the radius, and Z lies on the circle. Now, accordingly, if there is a less sign, then Z represents internal circle area. Z can lie anywhere on or inside the circle. Okay, if it is greater than sign, that means Z lies on or outside the circle. Now, let's have a look at this. Okay, let's have a look at this. What is this? Very easy question. So Z minus, can you see this is my Z naught, which is 5,7, and this is your radius 9. Okay, so 5,7 and this is your 9. Okay, find the greatest and least value of this. So what is Z over here? So ma'am, Z is anywhere lying on this circle, exactly on this circle. What are they asking? Mod of this minus this. Can you see this is mod of Z minus 2 plus 3 iota. So they are basically asking the distance between Z and 2, 3. 2, 3 suppose is lying over here, and Z, the value of Z, okay, this is 9. So Z is lying over here. So minimum and maximum. Now understand, minimum and maximum distance lie along this line. Okay, lie along this line. This is the line which passes through the center of the circle. Now you want minimum distance between Z and 2, 3. This is what? Modulus represent distance between this and this. Minimum distance between Z and 2, 3 would be when Z is lying over here. So this is for minimum distance. And if you're looking for maximum distance, Z should be farthest away. So this is the maximum away. So this is Z for maximum distance. Okay. So now tell me, minimum distance will be what? So minimum distance will be what? Distance between 5, 7 and 2, 3. Okay. So CP. C is the center, P is the point. CP minus radius is the minimum, and CP, this plus this, okay, is the maximum. See, understand. CP minus 9. CP minus 9 is what? Okay, and CP plus 9. Okay, so like that. So I think it has become very easy. In fact, I to feel you don't have to plot it. This is the ninja technique. Remember this. Distance between 5, 7 and 2, 3 minus 9 if minimum distance is asked, and plus 9 if maximum distance is asked. Yes? Okay. Are you getting my point? So now so it has been very easy now. Square root of 9 plus 16. So this distance is looking like 5. So 5, correct, minus distance is 5. Okay. So 5 minus, okay, 5 minus 9, that is going to be 4. Okay, anyway, modulus 5 minus 9. And so 2, 3, maybe it is lying inside the circle, that's why it is happening. And you know what, 5 plus, so this is your minimum distance. and 5 plus 9 is your maximum distance. You would be like, array distance is come because 2, 3 is not lying outside. I didn't check, but anyway, the formula works. Greatest and least distance. Okay. All right, everyone. Clear? All right. Now, I think we'll keep it till here, and we are going to move forward, and we are going to talk about cube roots of unity. Okay. And geometry problems, PYQ especially, we are going to do in the next session. Okay. All righty, everyone. Yes. So on this